الخير. Thank you for joining us for the session مع الدكتورة هيا المطيري. بس عشان أعرفكم عنا، إحنا مجلس كويت مباني الخضراء، إحنا شركة غير ربحية معنيين بموضوع maybe I should switch to English. We're concerned about the issue of the built environment and sustainability in the built environment. We are a membership-based organization. We are a non-profit organization. So if you are, as individuals or corporations, interested in the work that we do, we invite you to look into our website and consider joining as members. The session today focuses on a research I heard about more than 2 years ago in a municipal council session. I found it fascinating that we have this kind of research in Kuwait, that applied research, not just theoretical research. And I really was hoping to have bigger platforms. Inshallah, this is the start of even more conversations around this research and its potential. But I would just like to introduce Dr. Haya, Associate Researcher at KISR, who will talk about this discussion. We will start with her presentation and then move to the Q&A. So if anyone in person or online has any questions online, you can just leave it in the chat space, and we will definitely answer all your questions. Thank you.
If my voice is clear, it is good now. Okay. So we were talking about the two main processes that we utilize: the rubber in the asphalt pavement, whether it's wet process or dry process. At KISR, we use both ways, but we focus lately on the wet process because improving the performance of the bitumen is important because it controls the performance of the asphalt. So at KISR, we have so many trial sections. After we did all the laboratory work and we came up with the mixture design that we need for our climate, let's say, we started the very first trial section in 2019. It was in KISR internal roads. And the technology here was the pellet pave, where we use the rubber as pellet added to the mix. However, the first road that we utilize rubber in its virgin shape, when we just grind the local waste tires, was at Khalid Al-Marzouk Street between Al-Mansouriya and Al-Qadsiya in January 2023. After that, we have road number 106 at Al-Rag'i in January 2023. And the project that I led in KISR was in March 2024, KISR Shweikh campus. Okay, and at this project, actually, rubberized asphalt technology transitioned from a pilot research to implementation in KISR internal road maintenance contracts. So the beauty of this research, it was done within KISR. So we have like a full control over the whole process. We have oversee the all different processes of this project, from planning to implementation to monitoring after the placement. So the total area of that was maintained is about 1,400 meters square. And because we don't have like a guideline at MBW on how to use or to choose the correct maintenance procedure for each section, we developed our own decision tree. So this is to help us to divide the different maintenance requirement, let's say, into different zones. These zones are associated with different production day as well. So here we have each zone is associated with a different project production day and associated with different maintenance protocol. Sometimes we have reconstruction, sometimes we have milling and replacement. It all depends on the decision tree that we have discussed earlier. The beautiful thing here in that we were collecting samples from the asphalt plant during the production. We were also collecting samples from the asphalt mixture on the site. So we have kind of direct traceability of the performance and the kind of mix or the type of mix that we were using. So when we collect the sample, we did a full characterization for all the samples that we collected in terms of rheological properties, chemical properties, and also the morphology of the mixture. Okay, not only this, another nice thing were done during this project is that when we finished the project, for a duration of 2 years, we were like checklist based, doing a checklist based assessment, a visual assessment for each different zone. And we were producing a technical report for this. Whenever we have an issue in any of these zones, we go back to the mixture, we go back to the mix day and know whether the issue is from the mix itself or there is other factors that are affecting these like distresses, let's say. Other thing that we have done at KISR is doing advanced technologies and utilizing them in this research. And this is really important because you are looking at the big picture of the mix, or you are looking at the performance of these mixes, but being able or having access to these sophisticated instruments would help you better understand how it behaves. So here we use the scanning electronic microscope. We looked at the rubber itself before being utilized in the mix, and we go and look at it after being utilized in the mix. We see whether the size of the particle have been changed, whether there is the distribution, if it's will distribute or there is accumulation, or we have any kind of a problem. This actually helps us improve the mixing time, the mixing temperature, and help selection the best option for our mix here. The other interesting thing that we've done at KISR was the thermal imaging. During construction, we were thermal imaging using drones, and these images are very important, and the data extracted from these images were really helpful to understand two main things. The first one is that we need to know whether the cooling rate of these mixture are similar to the conventional mixes. This is very important because during the construction, you need to know if it's cooled very quickly, then you have to do the compaction very quickly and you don't have to wait. And for a certain time, you don't need to do the compaction in order not to break your pavement. Also, and by the way, we found that the cooling rate is a bit faster than the conventional one. And this is an disadvantage in terms of the workability. You have limited time to do the work. But in terms of opening the road for the public, this is much better than the conventional way. Okay, the other idea that we were investigating is whether we can use the images taken from the drones as a quality control tool. So for the engineer in the MBW, he's sitting in his office, he can just send a drone and see whether the work is done on the proper temperature at the right time, because distresses and problem in the pavement does not only associated with the mix design itself. Sometimes it's the process, the placement, the compaction, the timing, everything is associated. And after that, of course, the drainage, the rain, everything, you have to know everything that happens to that road in order to put your finger on the main reason of the problem. The last thing we did here is the FTIR. FTIR. It's a test that investigate the chemical component of the mixes. Okay, what we found that we collect sample from each production day, and we were checking the chemical component. This tells us how many rubber is there, how many polymer is there. Are we doing good job in terms of maintaining the same mix every time, or there is a variation? And the variation we found was also found in other projects in Kuwait, and this is mainly because we don't have a central mixing process, let's say, because the bitumen is modified differently each time in a different mixing plant, and that could be the reason. But it's a very important tool to investigate the consistency of our mixtures. Also, KISR have sent our mobile air pollution laboratory. This is to investigate the emissions during the construction as well as in the factory. So KISR's emission monitoring shows that rubberized asphalt has a lower footprint than traditional asphalt. This is due to reduced overall carbon emissions with a notable decrease in carbon monoxide emissions. So I will here talk about the SWOT analysis. I feel it's kind of important because it will answer some of your questions. So the strength of this technology, let's say, the environmental benefit, of course, you are utilizing a material that is considered as a waste, and you are not only utilizing it to get rid of it, you are improving your road infrastructure. The durability and performance of the roads that is constructed using this material are excellent, and the cost saving in the long run is very noticeable because you will reduce the frequency of maintenance. The weaknesses, I would say, the higher initial cost, because not all technologies are cheap at the beginning. You have some time to pay more for the long-term or long-run benefit. The availability of recycled tire, yes, we have a bunch of them. We have a lot of tires, but the particle size that we need is not always available. But if the demand increases, there will also the companies will be encouraged to produce this particular size. The technical challenges, as I said, we noticed that the cooling rate is a bit fast. So this is technically challenging for the contractor to keep the mix in the compaction at the right time. The opportunities, there is a growing demand for sustainable infrastructure. This is an innovation and market expansion opportunity. And there is a global awareness of tire waste challenges, and being able to launch this kind of technology, we are supporting the Kuwait vision for a more sustainable future. The threats is its higher initial cost, and there are material in the market that are easier to deal with, and the competition from the alternative materials is an existing threat, to be honest. So the tire waste crisis, it's just one piece of the puzzle. So do you know that the current road maintenance projects in Kuwait are expected to generate about 11 million tons of reclaimed asphalt? I know everybody here is excited because we are having new brand roads and smooth roads, but have you think, where are we stockpiling these wastes? So these are some pictures from Salmi roads. These are just 2 months after the started of the maintenance project. And here we have these were taken recently, 2 months ago. We are storing asphalt randomly in an open areas and to a residential area. This is near to a non-residential area. So the question here, have we learned from what the tire waste crisis taught us? Or we are repeating the same mistake? I will keep you with this question, and I would say that the future of sustainable roads may not start with the new materials. It may start by rethinking our waste. Thank you so much for listening. As I promised, I kept it brief so that we have more time for the discussion. I'll be happy to answer all your questions.
I think we'll just put some chairs and have a more relaxed discussion about it. Is my microphone working?
Yes, so strong.
Yeah. So thank you, Dr. Haya. We wanted to keep this discussion, the presentation part, a bit brief because I think there's a lot of questions about this research. I think I'll start with my personal questions. Were there any considerations of maybe fumes coming out of this asphalt that would impact human health? Is that something that was considered as part of the research?
It was. Actually, we put the air monitoring mobile units beside the in the asphalt plant as well as in the construction areas. It was so hard to distinguish between like the conventional way of producing, like the area there is so pollutant.
But it was
yeah,
difficult.
It was difficult to distinguish. But it was interesting that in the construction site we found that the overall emissions was kind of less than the conventional ones, and we have a report for this.
Okay. And is there any difference between applying this on highways versus like inner roads, where like, because there is this consideration, will they be durable for highways?
Unfortunately, we didn't have the chance to apply it in highways because we have to do this with the MBW approvals, and it's not always easy to take the approvals for this kind of trial sections. But I would say in Qatar, in Saudi Arabia, they tried it on highways and it was successfully applied. In Kuwait, we have recommendation that we don't do it in small residential area where we have a lot of turns and like narrow roads, because as I mentioned, it's kind of a mix that cools very quickly.
Okay.
And you want to do the compaction right after the placement. So yes, there are some recommendations. We wrote about it, and we prepare like a technical final report that summarizes the whole experience as well as the recommendations. And one of them is to use them in internal roads and highways also.
Okay. Anyone has any questions?
So my background is really limited. Just a question regarding that problem, the initial problem that you found this push problem. So let's say, I think as this picture, you have two problems. One is the amount of tire waste, and two is the asphalt composition, which is just bitumen, right?
And
so like bitumen itself wasn't enough for being, say, durable or something for the roads. So you wanted to test it on the vaporized material for the tire waste.
Okay.
Do you mind repeating the question for the online?
So the question was, we were discussing two problems. The first one is the accumulation of tires, and the second one is the quality of bitumen. It's not the bitumen itself. We need to improve the quality of the bitumen, and one way is to incorporate rubber into this bitumen. So we are not 100% replacing bitumen with rubber. We are like, we reach the maximum percentage we reach now is 12%. So we are replacing some of it. So this will reduce the demand on the like virgin material, which is bitumen. And at the same time, we are improving the performance of this material. And road is composite of two main materials, which is aggregates and bitumen. Bitumen is the material that is holding the aggregates together. So it's the binder kind of thing. Exactly. Exactly. 12% of the bitumen only. Yes.
So I'll take we have a few questions from our online participants. Are there any guidelines in MPW to use rubber, asphalt, mixed design, approvals, etc.? So maybe just tell us more about this process.
Yes. Like the process of approving like this mixed design needs the approval of MBW, the Public Authority of Industry as well. And we are currently in this process. We have submitted our recommendations and our like new upgraded specifications to incorporate not only asphalt, also RAB, which is recycled asphalt, into the new specifications. The current specification doesn't allow for the use of recycled material, unfortunately, but we are in the process with them, inshallah.
Yes, please. أنا أتكلم بعربي. بالنسبة لكمية التواير الموجودة في البريد كمية مهمة. صحيح. عملية إن في صعوبة في عملية الفرز. في عندي أنا تواير من تايوان، في عندي تواير من أوروبا، في عندي تواير من أمريكا. فطبعا كل ماتيريال من هذول تختلف اختلاف كلي عن الماتيريال الثاني. لو أنا أسوي ميكستشر منهم زي خلطت قصصتهم قطعتهم سويتهم خليط، أتوقع إني راح ألاقي صعوبات في عملية التمازج مع مادة البتون. زين. لكن المفترض انه لما اجي اشتغل هالشغله هذه انه عمليه فرز مهوله، بحيث انه طبعا الجماعه مكودين زين. فعمليه اني انا ابي اشتغل شغله نظيفه اخذ منها نتائج 100%، انا لازم افرز. يعني لانه ممكن يقول كذي عمليه ان بعض التوايل قديمه، عمليه القدم هذه تاثر على مكوناتها وتاثر على تفاعلها مع المواد الثانيه. يعني ممكن تحطين لو انا مثلا جبت النوعيه مثل الامريكي او النوعيه هذا اوروبي او النوعيه هذا تايواني او تشاينيز اللي مذكور رديء جدا، فعمليه المكسر لما تخلطين مع المواد تلاقين هذا الرديء يذوب بسرعه ويقوي الماتيريال الجيده، ممكن تتفاعل معي بصوره اقل، بس نتائجها في عمليه المزج والتوزيع راح تكون اقوى. صح كلام؟
So the question
yes.
لا
لان كميه يعني نقول شيء احنا يعني ورا التسال 100 كميه مهوله، عشان انا اشتغل لازم ناس متخصصه تقوم بعمليه الفرز، بحيث اني انا لما ابي اشتغل على اساس اني انا كنت الهاي واي عندنا ما بحد ما بدلنا، يعني ما سويتوا عليه تجربه او شيء. لو انت بتشتغلين على الهاي واي لازم تاخذين جود ماتيريال، صح هو كله على قولتهم عمليه ريسايكلينج، بس لما اجي انا اسوي لازم افرز المكونات، اخذ افضل الموجود على اساس ان انا اقدر امزجه ويتمازج معي مع المواد، على اساس اني انا اقدر اشتغل فيه يعطيني نتائج افضل. زين. يعني صح هي كميه كبيره جدا ومهوله ما تتخيلينها، يعني لو افترضت تغطي البلد كلها بالسخان والدخان والملوثات. فاذا انا هي الفكره ممتازه اني انا احولها واطورها، اني اعيد شغلها في ارتب فيها شوارع وفي اشياء ثانيه انا ممكن اسوي لها شرايط طوليه واخلطها مع المباني. يعني انا ممكن لاحظوا ان الفتره اللي طافت هذه واللي جايه راح يكون في عندي زلازل شويه عمليه هذه، فلو انا خلطت المواد هذه زين اللي هي التوايل هذه بطريقه معينه مع الكونكريت وهذا نزلتها في المباني راح كلها شيء ثاني.
So just to repeat the question for our online attendees, the question was about sorting, and there are millions of tires in Kuwait Desert, but they come from different manufacturers, but also they have different degradation. Some of them are very old, some of them are new. How do we do sorting for those kind of tires to ensure that the mixer that we get is of higher performance, especially when we venture into highways, for example? How do you deal with this challenge? But also the question also included the idea of using those discarded tires into building materials, not just for roads.
Yes, very good question by the way. بالعربي أجاوب؟ أكثر. المواد الربر اللي احنا قاعدين نستخدمها في هذا المشروع مشتقة، يعني حصلنا عليها من شركة أسيكو، أحد الشركات المختصة في التخلص خلينا نقول من نفايات الإطارات. هم مهتمين ككواليتي أشورنس، عندهم إن يستخدمون كثر ما يقدرون الأحدث وصولا لمكب النفايات خلينا نقول، أو
الأحدث وصولا قد يكون
راح أجاوب
1 2 3
صحيح،
قد يكون من الماتيريال الجيده، لان وايد سيارات انت تبين تشتري تاير حق سيارتك.
I get you.
لا هي هم اشتغلوا على
I'm coming to your question. راح أوصل له. فالفكرة إن أنت لما تسوي shredding وتخلط المادة تطلع منها الستيل اللي هو الشرايح وتبقي على مادة الربر. Yes, الربر it comes in a different quality from different companies, but rubber is rubber at the end of the day. And the idea أصلاً فكرة إن أنت ما تبي تصعب على منفذ الأعمال إنك أنت تطلب منه نوع معين من الربر. الربر بالنهاية بوليمر ويعمل كما يعمل البوليمر اللي يضاف كمحسن للطرق. فإحنا في دراسة ثانية خل أوضح لك إياها بعد، الحين إحنا قاعدين نشتغل عليها، اللي هي مثلا البلاستيك باجز. أوكي، فإحنا ما قاعدين نركز إن البلاستيك لازم يكون براند نيو أو جديد أو مدى استعماله، بالنهاية إحنا قاعدين نسوي له بروسيسنج وشريدنج ونرجعه إلى كثر ما نقدر إلى مواد الأصلية ونستخدمه. I think yes، يعني أكيد كل ما كانت البرودكت higher in quality بيكون المنتج أهم، بس اللي إحنا لاحظنا إنه لما يكون shredded randomly من مصنع بشكل مو بشكل يعني بشكل عشوائي، وهذا المطلوب، إن إحنا حصلنا على النتائج اللي حصلوا عليها إخواننا في قطر وفي السعودية وفي الدول العالمية الثانية.
Yes.
First, what's the
Ministry of Public Works وزارة الأشغال.
what are the difficulties, the major difficulties you had, the workability, and how did you fix it? لما أنتوا اشتغلتوا عليه شنو الصعوبات اللي واجهتوها أول ما بديتوا تسوون
Yes.
Can you repeat the question also?
Yes, sure. I will repeat the question. The first question was about MBW, which is Ministry of Public Works. And the second question is, how did we face, like, how did we overcome the challenges of workability that we have? Yes, it's similar to high polymer modified bitumen. If you have higher modified bitumen with polymer, you will have the same issue when it comes to workability. The thing is, we elevate the temperature when doing the mixing. So usually we do the mix at 150, but for rubberized asphalt, we go to 165 and 170. And for the placement as well, it arrived to the site with a bit higher temperature, 150, 155. So this is the main way we found to overcome this problem.
وفي احتمالية أن نستخدم
Yes. She was asking if we can do the hybrid mix, which is the wet and dry process. This is applicable, and they've made a lot of roads outside of Kuwait using this method. I found it a bit challenging because we are already having a problem with the workability, and the dry process doesn't fit really much liquid because rubber, having it in a bigger sizes, would have what we call rutting, which is the degradation in the pavement, because rubber is susceptible to this kind of distresses. But we found that the wet process is the best for Kuwait.
I have a question from online that I honestly don't understand. Maybe I will mispronounce a few things. Have you also evaluated, or do you plan to evaluate alternative technologies such as pyrolysis for converting rubber into pyrolytic liquids that could be used as asphalt rejuvenating agents?
Pyrolysis, I think. We have talked about this with one of the with the International Road Federation. We're discussing with that whether we can bring this technology to Kuwait. At that time, I was thinking that it's a bit too early for Kuwait, but it's it's burning the tires without oxygen and extracting the liquid from it and produce energy out of it as well. So yes.
Why is it too early for Kuwait? You mean
we're struggling with the conventional mixing ideas. So
you think the local contractors or manufacturers are?
We don't have a local factory that would help us produce this kind of. It's early, I mean by early, not this year, next year, maybe in the few years, inshallah.
And have you compared the cost for the conventional method and the method you're proposing, in terms of percentage-wise? You said it's more expensive as initial cost. So
yes,
can you just give us more?
We didn't make the compare in terms of the initial cost, but we are assuming that adding more materials as an additive would require more polymers to be added also to the mix. So this is why we are expecting a higher cost, but we didn't actually.
Are you planning on maybe because that's the risky thing with the market? Maybe MPW or the contractors are maybe less more reluctant on using this technology because they will assume the cost is higher, but also the technology is more complicated.
Yes, we think as a research institute now, we need to push for it to be available for the contractor and keep the freedom for the contractor to compare the performance and the initial cost for himself, as well as the technology application. But we are now struggling actually to make it like in the specifications, because they are treating it as a waste, not as an alternative material. And this is the mentality that we are like trying to.
What is the issue of them thinking of it as a waste, yani?
Because rubber is kind of polymer, and if what we are proposing is just consider it as
As
additive.
just another
Additive.
material.
Other material,
And you
and
think-
keep the other specification as is. So if they met the requirement specification, should be approved.
So you think it should be optional?
It should be optional at the beginning, yes. But if like
But why would they opt for it if it's more expensive? And maybe technology-wise, it's more difficult.
here where we need to give some incentive for the contractor if they are becoming more sustainable.
Yeah.
Yeah, I think it's for now we need to give them the opportunity to try. Maybe the contractor by himself would try it and find it more like durable, and even the workability, they might come up with a better mixed design that can overcome the workability problem.
Yeah. I think definitely for projects that are considering green financing or green building certifications, thinking of these innovations or this latest technology can be useful in them acquiring whether access to green finance, but showcasing how much they're reducing waste going to the landfill by using those expired tires in construction. That's something definitely. I know for a fact that also discarded tires are used for other building materials in Kuwait, and I think I've run into using them, and I think those gym kind of mats.
Yes.
How much do you know about that work, and do you have any reflections on that approach?
Actually, I just know that ASICO, the company that was like providing us with the raw materials, they work on this, but like I don't.
You're not, yeah. So there are possibilities of actually
Of course,
using.
yes. And there is no only one way of using. Like we are encouraging to have this technology in Kuwait, but there are many other ways. One of them, the pyrolysis, that we mentioned. It takes more, like it burned it to create kind of energy. So there are many other ways to
Not just as building material, but also a source of energy.
Yes.
Any more questions that we have?
So you did STIR,
Yes.
you did advanced microscope, and what other measures did you ask? Did you do chromatography to check for the purity?
We did.
Can you repeat the question?
Again, your question? Yes.
Different techniques that chromatography check for the purity. Did you do them or once?
We didn't do the chromatography, to be honest. He is asking about the advanced testing that we have done for the samples that we collected during our project. We did the FTIR to analyze the chemical component of the bitumen for each production day. And we are expecting a repeatability in the composition, but sometimes we are having some differences in the acceptance, like acceptable ranges. But for other tested that you mentioned, no, we didn't actually did this.
Is that a reason?
Not really, because what we're focusing on a test that would give us indicators. So using FTIR was my main objective was to check the variability in the composition, because we want to see if we use every time 12% rubber or we increase it. We did less. And for the microscopy, we did it because I want to see the distribution of the rubber within the bitumen and without the bitumen, the sizes, how it interact with the heat and the mixing, everything. So that's why, like, the scope of the project didn't include it, but maybe in the future.
When was the last time you tested the roads that you already did in Reg'i and Qadsiya? I think you mentioned that.
These roads, I think, a year ago. But the internal road 3 months ago.
3 months ago. And how are the results? Are they satisfactory?
Very satisfactory because we don't have any problem with them. We have a minor raveling, which is like the raveling problem happens when you see the roughness of the surface. And these distresses specifically were associated with the drainage issue in the site. So it was not associated with the mix itself. So we don't have any other problems
That's very good.
Just
One of the issues I've also heard during that session that we have some, like millions of tires, some of them have been thrown into the hot desert years and years ago. So they're not even eligible to be used for those mixes. So what do you do with, is there any other solutions for those very old tires that like are not?
Yes, as I mentioned, performance is very critical, important when it comes to roads, to construction materials. So there are other ways in terms of energy, as I mentioned, they can use it in other ways. But for building materials, we are committed to high performance
of safety
and safety of the application.
Yes.
بالنسبة للواير كميتها موجودة في الصحراء هي ما تتأثر بعوامل الطبيعة. يعني ما مطر هواء حرارة قاعدة. ففي ناس يعني بدأوا يفكرون في عملية التدوير، فممكن تستخدم إعادة تدويرها في عمل حق الزرع، يعني يسوونها حق الزرع
like more decorative يعني.
في ناس مجموعة بسيطة طبعا على الديكور وكذي خذوهم وبدأوا يسوونهم تيبل وقاعد تشيرز وكذي. زين في ناس سووا ألعاب أطفال يعني في بس طبعا الموضوع محدود يعني انتم عندكم قدره ان انتم لان انتم فكرتكم في الشارع، لكن انتم قاعد تتحدون الناس في السياسه كذا تتحدون في شركات كبيره والعمل صعب والعمل معقد والعمل يحتاج اشياء كثيره. زين الثاني البيتومين والصخر والطلب النقص ونزل بالشارع وعادي بعد احنا يهمنا انه بعد 6 شهور بعد سنه يبدا يخرب ويبدا يسوي له مره ثانيه، لكن ان انا اسوي شيء دائم ديمومه فيه او ديمومه طويله، يعني مثلا الشارع هذا احطه واقعد 5 سنوات ما احتاج اني انا اشيك عليه يعني تطلع لي مشاكل منه، يعني اوكي يكون ناعم وممتاز وما في محفر ولا مطبات ولا شيء وراح يكون صديق للبيئه وراح يكون مناسب للسيارات والكلام هذا كله. فالموضوع وايد يعني هي قالت اساسا شو نسوي فيه بعدين يعني شنو ممكن اشياء احنا نطلعها من التواير هذه المركونه.
Because I think that a few of the manufacturers mentioned that the most attractive wasted tires are the tires that just arrive to the landfill because of the highest quality and but of course there are many other ways to reuse the tires for
yes بس في العاب الاطفال اعتقد في خطوره هنا في استخدام
يشيلون جزء من
حتى لو
يسوون له يحطون مواد يسكرون الفتحات هذه ويصبغونها او في ناس تلبسها اقمشه وسفنج وبالعكس
وفي نقطه انا ودي اذكرها مهمه هنا ان the contractors are keen to improve their sustainability practices ترى يعني عكس ما احنا متوقعين ان they are not open to new ideas. A lot of amazing idea came actually from the contractors.
Yes. بس ما حد راضي يتقبل.
One of the manufacturers have little resistance to what you're
little resistance.
Really?
Yes, one of the contractors came to us and he was doing not resurfacing, major rehabilitation for the roads, and they were struggling from the first few kilometers of the amount of waste that they are generating, and they came up with an idea of doing in-place recycling, and they are willing to buy a 1 million instrument to do the recycling on site, to use the current material for a sub-base or sub-grade. I was amazed by how the contractors were open to sustainable practices.
So it seems like the main hurdle to using this research is the policy within MP.
It's the policies, the specifications, the guidelines.
So you feel that even the market is ready for the use of this mixes.
متخصصة في أخذ الويست هذه وتنظيفها وترتيبها وفرمها وتكسسها وتجهيزها للي راح يستخدمها عقب. فكذي أنا ممكن يعني أسوي بزنس جديد صناعة جديدة.
And actually يعني الcontractor ترى it's a hassle for him to remove these waste and dump it somewhere. It's better for him to have another technology or innovative solution for this problem. Like it's not always the contractor is resisting. It's sometimes the guidelines, the specifications, the rules that didn't allow us to adapt these technologies.
Yeah, and I think how you ended the presentation with the current roadworks that are happening, and I'm sure all of us are affected by it. Although on surface it's a very positive thing that we will have better roads, we rarely think about the actual implications of that. And the same thing with tires. We keep changing our tires, but without really, because I think we're very much isolated from our environmental impacts. We do not see those tires in the middle of the desert. And I remember reflecting back on that session. The session had the fire department as part of it, and they had a major issue when a fire would erupt on those very remote sites, and they don't have ability to transfer water to that site to even distinguish the fire. So even now, the solution was to fragment them into very small areas. So even when a fire erupts, it doesn't spread out to other areas. So it's not just it's an environmental issue; it's a human health issue, and we're not seeing it because it's remote, it's further away. The same thing with the current road, the asphalt that we see. We don't know where this is going. We don't even know if there's a site dedicated for that. And my understanding is the contractors are not allowed to resell that that waste.
Is not allowing anybody to sell it. And at the same time, there is no system to store it, to organize it, in order to talk about
what to do with it. Yeah.
Yes,
So it's very random. It's very unfortunate because, I mean, it's
a valuable resource, by the way. It's a high quality bitumen, it's a high quality aggregate.
Yeah.
We choose it very carefully in order to build our roads with. It's not like just a waste, really low value material.
And probably contractors would love to resell it.
They would love to.
Yeah.
Course, yes.
Historically, I think they used to resell it.
For الطرق الزراعية.
Yeah. So I think it's also another issue we need to think about is the life cycle of our of everything, of our building materials, of our projects. When I use a tire, when I purchase it, I look into how it was manufactured, where it was manufactured, but I rarely think about the afterlife after I finish using it. And the same with all these road constructions. It's very rare that we see a procurement or a tender from the state where they think of the aftermath of that construction site, what would happen to any waste generated by that site, and the same thing with the existing building. We demolish them without really thinking about what would happen to this construction waste, where would it go? Does it have a value? Can it be reused? Can we move it away from the landfill as much as possible? So I think this is at the core of what you are doing. And I know you're not you're really working on a very technical research here, and you're looking into the best practices and how to, but also your research fits into a much bigger conversation about sustainability in Kuwait. I don't know if there are any more questions, reflections. Yes.
Okay. So she was asking about the mix design and what's the percentage that we incorporated the rubber into our mix. Actually, before we approve the mix, we go to the lab and do our trials. And until we have the mix design, the approved mix design, we do all the tests required for the approval of this mix design. So the maximum we reached was 12.5 of the bitumen. Bitumen consists of 5% of the mix. So that was the successful, and that was the highest globally, 12.5. Even in Qatar, this was the highest they reached.
How much you learned from the Qatar and Saudi experience? Because you mentioned them, but I'm curious to know.
I'm mentioning Qatar a lot because we are using the Qatari specifications.
Okay.
This is a main thing, and whatever we're trying, like, yes, our specification doesn't match our contracts. That's why we have the gap here in Kuwait. But when it comes to technical things, we are talking about Qatari specification and Qatari practice. And for the rubberized asphalt, yes, of course, we learned a lot from them. And a part of the recommendation that we recommend was also agreed with them. And some are not.
And we have very similar climates and conditions. And
that's true. Yes, one of the differences.
Can you repeat the question?
Yes, the question is, is it better to have our own factory for the bitumen, you mean, or for modifying the bitumen? And this is an excellent question, by the way, because the difference between us and Qatar, they have a
centralized kind of process, yeah.
Yes, and in Kuwait, no, it's a bit like each asphalt plant do their own blend and mix. Of course, it would be more. We would have more uniform, like blend. For any factory راح يكون في أثر بيئي but like it's in terms of performance it would be much better. The question is, what's the best solution for the accumulated tire and for the RAB that is accumulated, also stockpiling everywhere? As I mentioned in the presentation, from a civil engineer who work in roads, I would recommend and encourage the application of this waste material in roads. But other like researcher have different ideas, different applications, maybe will help incorporating the material in higher like percentages. But for me, I would definitely go with adapting these technologies in our roads. Yeah. You're welcome. في سؤال ورا.
As we know, hospitals is for farm equipment. So if you put super tools in hospitals like wards.
Yes, for the parking in the hospitals. Well, this is a good idea.
So the question was to how are you using this technology in parkings in hospitals?
In the hospitals.
So
yes.
why specifically hospitals? I'm curious.
The number of certain might affect patient inside as in
Not sure.
I'm not sure because we're talking about the construction phase where we don't have patients, I guess, around the location. But like maybe because given that we found that the emissions is less, maybe this is a more friendly.
But you mentioned the emissions rest during construction.
During construction.
Have they been tested on long term?
No.
Yes, you mean during the construction, the emission is less, so it's safer for the patient. Yes, this is a good suggestion because yes, we have monitored the emissions and we found that it is less when it comes to compared to the conventional way. But on long term run, I don't see any difference, to be honest.
So far, there's no research supporting, and there's much to, because I heard some concerns that maybe not using them in walkways or like near children areas, because with the heat in Kuwait, there might, like it might, I honestly, I don't know if this is
didn't do the
research-based. Yeah, I don't know if this was research-based or just assumptions that using this rubberized asphalt on the long term might have impact on human health. I'm curious to know if there are any global research on this topic.
In Kuwait, we don't have any related research to investigate this. And globally, I haven't read anything related to this because we are just modifying 12% of the 5% of the mix.
So it's
so 95% of the mix is aggregate, and
still
it's
still
the same. So I don't see that major. Like,
so, for example, let's assume there is a two-lane street, 1 kilometer of two-lane street. How many tires are you using for that? Like, how much is the volume that you're
for the dry process, we can reach up to 2,000.
Wow.
Tires. This is for the dry process.
Yeah.
But for the wet process, it's much less. We're talking about hundreds.
Hundreds.
Yes.
But we have so many roads in Kuwait. It's still a major contributor.
Exactly.
Okay. So yeah.
There is a question with it.
Just.
About the solar protection. As you know, the asphalt like Big Island, So did we test the solar reflection of the horizon?
We haven't, to be honest, but like if you see the thermal imaging that we were taking, it shows us that the cooling process is the cooling rate is faster. So this might help when it comes to the heat around this.
Increasing the temperature, maybe we can add another research to add another material, but we do a mixture, add another material to increase the temperature. As we
So yeah.
the mega renovation of our roads, add this mixture to this mega renovation.
Yeah.
So the question was about the
Cool.
cooling process, how it's
Yes.
faster, and maybe there's a possibility of introducing other materials to make the cooling process matches the conventional, let's say.
I'm currently working on a material that can be added to the mix to create what we call cool pavement. So it's still under investigation.
Honestly, I'm very keen on this drone usage on monitoring performance. And I was like, we also had a minor discussion about that and how to use more drones to basically monitor the quality, not of the construction, but also the performance of the roads on the long term and identify issues. I think that's a huge potential that will contribute to research, but also the quality of our roads and safety of our roads.
Yes, exactly.
I don't. آخر سؤال.
هذه الهواية هذه نستخدمها نسير تكون مادة عازلة كلها تحتاج مواد عازلة في الأسقف زين هي نفس الفكرة مادة الشعر لو أنا قدرت أخلق مادة عازلة من الربع هذا أول شيء عملية سماكة مادة عملية وعزل يعني أنا الحين حاليا يستخدمون مواد كيماوية ويستخدمون مواد بترولية بحيث إنهم يعزلون اللي مع الفم زين أنا ممكن شلت الفم أو خلطتها مع الفم يعني أخذ المواد هذه أفرمها بطريقة معينة كذي وأحطها مع الميكس نفسه وأعزل فيها الأسطح أعزل فيها الأعمدة الخرسانية ولما أجي أبني أعتقد أنها راح تكون فكرة.
So the question about of using a rubber tire in creating insulation materials and maybe considering that research aspect and how to utilize them.
Yes.
There are so many potentials for there are endless possibilities, and I think definitely, I'm very honestly proud of KISR, of the research that they're doing. They're looking into national issues and coming up with practical solutions, applied research that can be actually utilized. I really hope that gap between research and actual things happening on the ground will become less and less. I think definitely more white papers, more, I think maybe different ways of communicating this research to decision makers, inshallah will help move things faster and faster. I'd like to thank you again, Dr. Haya, for sharing this research with us, for answering all these questions. And I would like to thank everyone who attended online and in person at Kuwait Green Building Council. I would like to remind you again to consider joining us as members, whether you are part of a corporation or individual, because through these membership, this is how we manage to do these events and to move the conversation more forward regarding creating a more sustainable environment in Kuwait. Thank you again, Dr. Haya. Thank you, everyone.
Thank you, everybody, for having me.
Thank you. Bye.
Thank you.